Hello dear students, I am Ramesh Narayan Tripathi. You are viewing my physics channel, Physics R&T. Today we are going to discuss some multiple choice questions based on X-rays. At first let us see the related formulas and helping tips. As you know, X-ray was first discovered by Roentgen. First formula, if V is the potential difference between anode and cathode, then kinetic energy of electron striking the anode is equal to E into V is equal to half mv square. If total kinetic energy of electron striking anode is converted into X-rays, then wavelength is minimum and is given by lambda minimum is equal to hc upon E into V. Putting the values of Planck constant h, velocity of light in vacuum c and electronic charge E in this formula, we get lambda minimum as 12,375 upon V angstrom, which may be also written as 12,400 angstrom upon V. Next, Bragg's law, 2d sin theta is equal to n lambda, where n is the order of diffraction by a crystal of lattice constant d. Next, Moseley's law, frequency of X-rays is directly proportional to the square of atomic number. So, F is directly proportional to Z square and hence lambda will be inversely proportional to Z square. If B is screening constant, then Moseley's law becomes F directly proportional to Z minus B square, where Z minus B is called shielding constant. For characteristic X-rays shown in this diagram, B is equal to 1 for K series, B is equal to 7.4 for L series and B is equal to 19.2 for M series. Next, hard X-rays have greater frequency than soft X-rays. Next, X-rays are not deflected in electric and magnetic fields as they are electromagnetic waves. X-rays show diffraction and polarization being transverse waves. Next, energy range of X-rays is 100 electron volt to 100 kilo electron volt. Next, when X-rays are incident on metals, they exert force, pressure and transfer energy. Next, wavelength range of X-rays is 0.1 angstrom to 100 angstrom. Frequency range of X-rays is 3 into 10 to power 16 Hz to 3 into 10 to power 19 Hz. Penetration power of X-rays is inversely proportional to its wavelength. Now we take question number 1. The question is, the minimum wavelength of X-rays emitted by X-ray tube is 0.4125 angstrom. The accelerating voltage is. Solution to question 1. We know cutoff wavelength lambda minimum is equal to 12,400 angstrom upon accelerating voltage V, which gives V as 12,400 angstrom upon lambda minimum. So it is 12,400 angstrom upon lambda minimum is 0.4125. After simplification, it gives 30,060.6 volts, which is nearly 30 kilovolt. So the correct option is B. Next question number 2. The question is, a beam of 35 kilo electron volt strikes a molybdenum target in X-ray tube. What is the cutoff wavelength? Solution to question 2. Again, lambda minimum is equal to 12,400 angstrom upon B. B is because 35 kilo electron volt, therefore B will be equal to 35 kilovolt. So, lambda minimum will be equal to 12,400 angstrom divided by 35 kilo means 1000. So, it gives lambda minimum as 35.4 into 10 to minus 12 meter. So, it will be 35.4 picometer, because 1 angstrom is equal to 10 to minus 10 meter and picometer is 10 to minus 12 meter. So, the correct option will be 35.4 picometer, that is B is correct. Next question number 3. Which of the following wavelengths is absent in the continuous spectrum of X-rays if the X-ray tube is operating at 40 kilovolt? Now, solution to question 3. Lambda minimum is equal to 12,400 angstrom upon B. Here B is 40 kilovolt. So, it is 12,400 angstrom upon 40 into 10 to power 3. On simplification, it gives 0.31 angstrom. So, the absent wavelength will be below 0.31 angstrom. So, the correct option is C. Next question number 4. The question is, hard X-rays used to study the fractures in bones should have a minimum wavelength of 10 to minus 11 meter. 10 to minus 11 meter. The accelerating voltage for the electrons in the X-ray machine should be. These are the options. So, solution to question 4. Lambda minimum is equal to 12,400 angstrom upon B. Clearly, when lambda is minimum, then B should be maximum. Therefore, B maximum will be equal to 12,400 angstrom upon lambda minimum, and lambda minimum is 10 to minus 11 meter. So, it is 12,400 into 10 to minus 10 meter upon 10 to minus 11, which gives 1,24,000 volts, which is 124 kilovolt. So, the correct option will be B, that is operating voltage must be less than 124 kilovolt. Next question number 5. The question is, an X-ray tube has wavelength 0.01 angstrom. Its momentum is, these are the options. So, solution to question 5. de Broglie wavelength lambda is equal to h upon p. Therefore, p will be equal to h upon lambda. H may be written as 6.6 into 10 to minus 34, and lambda is given to be 0.01 angstrom, means 10 to minus 10. So, it gives 6.6 into 10 to minus 22 kg meter per second or Newton second. So, the correct option will be D. Next question number 6. The question is longest wavelength that can be analyzed by sodium chloride crystal of spacing 2.82 angstrom in the second order is. These are the options. Now solution to question 6. From Bragg's law, 2d sin theta is equal to n lambda. So for second order it becomes 2d sin theta is equal to 2 lambda, 2 cancels out, and we get d sin theta is equal to lambda. Lambda will be maximum when sin theta is 90 degree, therefore lambda maximum will be equal to d, that is 2.82 angstrom. So the correct option will be B. Next question number 7. The question is the potential difference applied across X-ray tube is 5 kilovolt and the current through it is 3.2 milliampere. The number of electrons striking the target per second is. Now solution to question 7. We know current I is equal to charge flowing per unit time and charge is N into electronic charge upon time. So charge is equal to N into E upon this T, and so we get N upon T as I upon E. I is given to be 3.2 millimeters 10 to minus 3 upon E is 1.6 into 10 to minus 19. So it gives 2 into 10 to 16. So the correct option will be B, 2 into 10 to power 16. Next question number 8. The question is if F1, F2 and F3 be the frequencies of corresponding K alpha, K beta and L alpha X-ray of an element, then these are the options. Now solution to question 8. Yeah. Suppose these are KLM N, KLM N series, that is K is equal to 1, N is equal to 2, L is equal to 2. For K, N is equal to 1. For L, N is equal to 2. For M, N is equal to 3. And for N, N is equal to 4. Energy of N is En, energy of M is Em, energy of L is El, and energy of K is Ek. Now this is K alpha, this is K beta, similarly this is K gamma, this is L alpha. According to question, frequency of K alpha is F1, its energy will be Hf1, its energy of K beta will be Hf2, and energy of L alpha will be Hf3. Clearly Hf2 is equal to Hf1 plus Hf3, thus Hf2 is equal to Hf1 this plus Hf3 this, F cancels out, therefore we get F2 is equal to F1 plus F3. So the correct option will be C. Next question number 9. The question is, for the production of characteristic K gamma X-ray, the electron transition is, these are the options. Now solution to question 9. Again, this is the characteristic X-ray spectrum. In this K gamma, this is K gamma spectral line, which is due to the transition between n is equal to 4 to n is equal to 1, this one. So the K gamma is due to the transition from n is equal to 4 to n is equal to 1. So the correct option will be C. Next question number 10. The question is, electrons with de Broglie wavelength lambda fall on the target in X-ray tube. The cutoff wavelength lambda naught of emitted X-rays will be. These are the options. Now solution to question 10. We know de Broglie wavelength lambda is equal to h upon p, which can be written as h upon 2 m into E, where E is energy of incident particle or kinetic energy, E is kinetic energy. Squaring on both sides, we get lambda square is equal to h square upon 2 m into E, which gives E as h square upon 2 m lambda square. Therefore, lambda minimum, cutoff wavelength lambda minimum, which is equal to lambda naught, will be equal to hc upon E. E means E into V. So it will be hc upon E means h square upon 2 m lambda square. H cancels h, giving h. So we get 2 mc lambda square upon h. So the correct option is B.